Oh my goodness. I missed our ending. Okay, let me rewrite this for a second. So 6.472 times 10 to the 23 kilograms. There we go. That seems a little bit more accurate. Okay, and then we're still going to round off to our 2 sig figs, which is our 6.4 times 10 to the 23 kilograms. Perfect. And now our last step is we're going to go back and we're going to write that therefore statement. So, therefore, the mass of Mars is approximately 6.4 times 10 to the 23 kilograms. Okay, and on to our last part. We're going to try and squeeze it in this corner, part C. So, now the question is asking if the woman were to fall from a height, so we're going to go back to our givens, were to fall from our height, so a delta D of 3.0 meters on the Martian surface, how long would it take her to land? Okay, so we're trying to find our delta T, or our time. So what are some other givens we know? We still know our acceleration on Mars that we used way back at the beginning. So this is equal to our 3.7 newtons per kilogram. Perfect. The one thing we know is that a newton per kilogram, if we use our units, we can simplify this unit to 3.7 meters per second squared. Okay, now we got to think back to the kinematics unit. So in kinematics, we used the equation delta D is equal to V1 delta T plus 1/2 A, our acceleration, times delta T squared. We're a little squished. That's okay. Okay, so in this situation, we know that she doesn't have an initial velocity. So we're just going to go right ahead and we're going to cross this off and zero it out, because this value is going to have no importance. So we're going to go back and we're going to simplify this. So now we have delta D is equal to 1/2 A times delta T squared. Perfect. So we already have our delta T and we know our acceleration. So we're going to isolate our delta T. So our delta T is equal to delta D. We got to keep that squared there for a second. Divided by 1/2 A. Okay, and if we want to make this unsquared, we got to use our square root. So our delta T is equal to the square root of delta D divided by 1/2 A, or AM. I guess I should use my subscripts. Okay, so now subbing in our values, we're going to solve for our delta T. So our delta T is equal to the square root of 3.0 meters divided by 1/2 of 3.7 meters per second squared. Okay, so our delta T is going to be equal to, let me type this into my calculator really quickly, 3 divided by 1/2 times 3.7. Oh, I did that wrong. 3 divided by 0. Okay. We're going to get the answer of 1.273 seconds. Remembering, if it helps with unit cancellation, these 2 meters are going to cancel out. And when you square root the second squared, we're just going to end up with a unit of seconds. Okay, so now going back to our sig figs, we still are just sticking with the 2 sig figs. So our delta t is going to be equal to 1.3 seconds. Writing our therefore statement, we can say, therefore, it will take the woman 1.3 seconds to land on the Martian surface.